moving on. Day before yesterday, when we talked about inscribed angles, I told you that the measure of an inscribed angle is half the measure of its intersected arc. And you may have heard me say that when we're finding angle measures in circles, we're taking half of a lot of things. And we're continuing on with that. Before we do, there's a little bit of vocabulary that I think I've hinted at, just kind of throwing it out there, but it hadn't been relevant before. Now it is relevant. Remember that at the beginning of the chapter, we talked about how a tangent line is a line that touches a circle at exactly 1 point. A line that touches a circle at 2 points is called a secant line, right? So in this lesson, we're kind of wrapping things up. So far, we've talked about angles on the circle. We've talked about angles at the center of the circle. The last thing that we need to discuss is angles formed inside the circle, just somewhere in a random place in the circle, and angles formed outside of the circle. Okay, so notice angle 1 is an angle formed inside of the circle at some random point that is not the center of the circle. Notice this extra segment that I've drawn in here. You may recall from a few chapters ago, the triangle exterior angle theorem. What? Yeah. The triangle exterior angle theorem, which told us, notice, angle 1 is an exterior angle to this triangle. Angle 1 will equal these two angles, its remote interior angles, put together. Well, notice what these two angles are as far as the circle is concerned. They're inscribed angles. So they're going to be half of their intersected arc. And when I take all of that and I put it all together and I shake it out so that something neat comes out of it, what we end up having is that the measure of an angle formed inside of a circle is 1/2 the sum of the arcs. And let me be very clear about which arcs I'm talking about. Notice that angle 1 is intercepting arc AB. Notice that the angle that is vertical to angle 1 is intercepting arc CD. So what you might want to jot down just to be clear in this diagram is that angle 1 is half of arc AB plus arc CD. The measures of those arcs. And then finally, the last kind of angle we'll deal with is an angle formed outside of the circle, and it will be half the difference of the arcs. So to summarize, central angles are the same as their intersected arc. An inscribed angle is half of its intersected arc. An angle formed inside of the circle is half the sum of two arcs. And an angle formed outside is half the difference of two arcs. Let's take a look at how to use that. In problem 1, here's how I'm going to ask the question. Where's the angle? In, out, on, or central? In. It's in. And an angle in is half the sum. So x is half. Is it all the arc? No. Thank you for. It's the intercepted arc and the intercepted arc of its vertical angle. Okay, so here I'm adding 165 plus 87. And mind your order of operations, please. I had to have that conversation with my regular geometry students. It made me sad. Under 26 degrees. And some of you may be looking at part B, and and you're noticing that y is an arc, and some of you might look at that and say, well, what do I do with that? Yes, ma'am.
How do we, like, on a test, how do we tell the difference between the last one here and this? Because it looks like the same.
Okay, and thank you for bringing that up. Once again, remember that first question that I asked you when we started part A. Where is the vertex of the angle? In, out, on, or central? Notice here, the vertex of the angle is in the circle. Notice here, where is the vertex of the angle? It's outside of the circle. So an angle formed outside is half the difference of two arcs. Whereas, and here's where the confusion came up in the class when I taught this earlier this morning. Problem like this, right? Okay, this angle was inside the circle, but Mrs. Clouse, you didn't have me do that process on that problem. You're absolutely right. Because in this problem, you had the triangle at your disposal. The fact that the three angles of a triangle add up to 180. And sometimes you have that piece of information, and you can use that. I don't have the triangle here, so I have to use the fact that an angle formed inside the circle is half the sum of the two arcs. So in part B, you may have heard me already say that's an angle formed outside of the circle. And an angle formed outside of the circle is half the difference. So I'm going to set up an equation here. Ladies, ready? I have 22 equal to half the difference of the two arcs. Oh, Mrs. Hot, yes, question. Difference, remember, means minus. Well, and here's the question that I was kind of leading you toward, is how do you know which one you're subtracting from which? Oh, it definitely matters. And because, why does it matter? Why does it matter? Right, we can't have a negative angle. So doesn't it make sense? Yes, absolutely. Big arc minus little arc. Yes, ma'am. 98 minus y. Notice the 22 is the angle. The angle is half the difference between the two arcs. So from here, we're just solving for y. Okay, myself personally, if I can avoid having a fraction in an equation, I'd like to. So I'm looking at this equation and thinking, ooh, let me get rid of that 1/2 and multiply the whole equation by 2. That gives me 44 equal to 98 minus y. And then just get y by itself. Negative y equals negative 54. So y equals 54. Did I, what? In order to get rid of the 1/2. Well, I've multiplied both sides by 2/1. And that cancels out. Good? Okay. It's all right. It's Friday for me too. Not yet. Hey, in problem 2, I'm talking about the viewing angle of some kind of camera or lens or here. The viewing angle. And gentlemen, when you're talking about a viewing angle, you'll notice that they're always talking about that angle is formed by two tangents. So visualize, and this is pretty much always what the diagram is going to look like. Here's the moon in this problem. And here's one of the tangents, badly drawn. It should be touching the point at exactly touching the circle at exactly 1 point. And there's the other one. It's a better job. The viewing angle is 8 18 degrees. That's here. I'm trying to find the measure of the arc of the moon that is viewed from the spacecraft. So my spacecraft is over here. This is the arc of the moon that can be seen. And once again, just like in the last problem, my angle that is formed outside of the circle. And an angle outside is half the difference of two arcs. But what's the problem? I don't know the other arc. How might I express that arc? How might I express that arc? Yes, ma'am? No? Put your pencils down a second because I don't want you writing a phony number down. Let's suppose that I said that x arc was 120. You would have no problem telling me how to find the other arc. How'd you do that, Benjamin?
360 divided by 2x.
There we go. Just because it's a variable doesn't change the fact that you take the whole 360 and subtract the arc that you know. So now, once again, I need to set up an equation where I'm just solving for x. The angle outside, remember, is half the difference of the intercepted arcs. My two arcs are 360 minus x, and then minus x. Remember, those x's aren't going to cancel each other out. They're both negative. And once again, 1/2. Let me just multiply the whole equation by 2 so that I'm not distributing, bless you, a fraction. So this will be 36 equal to 360 minus 2x. Negative 324 equals negative 2x. Did someone run those numbers?
Yeah.
Make sure I didn't, drop my brain. Okay, we're good. And then x is 162. And you'll notice that you have a your turn just like problem 1, and a your turn just like problem 2. And if you're looking at the clock and thinking there's no way she's going to get through these segments, you're absolutely right. That was never my intention. Today is the angles part of the lesson.
Yeah.
Monday is the segments part of the lesson. If you are going to be out on Monday because of FCAT or whatever else is going on, you are certainly welcome to come in first period if your first period teacher allows it. Also, as always, you know I'm going to be recording the lesson. You know I'll be posting it online. Yes, ma'am. These are the angle problems. Yeah, no, like I said, I had every intention of stopping after the angles. Okay, so there's your turns just like these. Please take a moment within your groups and be working on those problems. Give me one moment.
2, 4, 8, 48.
Can I reveal all of your turn problem 1? Okay, I've already revealed part A.
Couldn't you have just done
Yes, absolutely. You could have just done 360 minus 110. It was a stupid question. I didn't realize it until just now. Yes, ma'am.
Shut up. I did it the right way. I would have added 2 and just add to 1 point. Don't even try to pass it off.
Okay, I am revealing part B.
Reveal it all.
Reveal it all?
Yeah.
Woo!
Yeah,
Wonderful. Anything I need to talk about on this screen? Is there anything that I need to clarify on this screen? All right. How about your turn on number 2? Not yet? Oh, look, it's on the back. You want me to show you the diagram for it?
No, we were talking about, we didn't finish copying the answers to the.
Oh.
That was like what I didn't know what was going to do. Whatever we're doing.
Okay, we good on this screen now?
Yeah. I have it.
I figured out.
Your turn. Problem 2. Please don't spray anything in here. Don't ever spray stuff in a closed space.
Oh, spray. What?
Right. This is Okay, I'm revealing the diagram for you. Should I just reveal the whole thing? Okay.
Wait, are we supposed to make the diagram ourselves?
Yeah, that diagram did not come with the problem. You need to be able to come up with that diagram. I'm not changing anything. I'm just stopping my recording.